The first question that is given here, it says that there is a wire and this wire was attached with a ceiling and the free end of the wire is given a weight. The weight is equal to W, and in this case we are supposed to find the longitudinal stress given that the area of the cross section of the wire is A. So it's very easy one. So longitudinal stress will be equal to longitudinal force, which is here, is W and then divided by A. So option 2 is the correct answer. Let's move on. Okay, so this question mentions that there are two bodies, one is solid sphere, another one is hollow sphere, and both rotates about their own axis of rotation, and then we have to find the ratio of the radius of gyration. If I want to draw the situation, it will be like this. This is my solid sphere and let's say this is my hollow sphere. According to the description that is given in the question, mass and radius of both the spheres are equal and we are supposed to calculate the ratio of the radius of gyration. So what I will do is that for the solid sphere, I will write down the moment of inertia about its own axis, which is 2 by 5 mr square, and I will make it equal to mk square. Let's say k1 is the radius of gyration for the solid sphere. Again, for this hollow sphere, the moment of inertia about its own axis is 2 by 3 mr square. When I make it equal to mass multiplied by its respective radius of gyration square, then it will be like this. Therefore, I will divide both of them. So mk1 square divided by mk2 square equal to 2 by 5 mr square divided by 2 by 3 mr square. And I simplify this one and the answer comes out to be 3 by 5, square root of 3 by 5. This question will be bonus because none of the options are correct here. Let's move on. There's a question, there's a circuit given in front of us and the circuit consists of 3 capacitors and we are supposed to find the equivalent capacitance between point A and point B. So how we will proceed? It's very simple. This capacitor and this entire unit, they are in series with each other. Let's say this is C1, so C1 is equal to 3. And this unit is, let's say, C2. Since this unit consists of 2 capacitors having equal value and connected parallelly, therefore the equivalent capacitance of this particular unit will be equal to 3 plus 3 equal to 6. Thereby the equivalent capacitance of this system will be equal to 1 by C1 plus 1 by C2, and when I calculate this, it will be C1, C2, C1 plus C2. I put the value and it comes out to be 2 microfarad. Let's move on. This question describes the situation as follows. There is a football player. This football player was moving in the southward direction and all of a sudden the football player has to move in the eastward direction. And in this process, the football player experiences some force and we are supposed to find the direction of that force. So what I will do, I will first, for the convenient, I will first draw the directions. Let's say this is north, this is east, this is south and this is west. Let's say this is the direction of the motion, initial direction of the motion of the football player. Let's say the velocity was v1 and then all of a sudden it moves towards eastward. So the velocity in this case it will be v2. The speed will remain same but the directions are different. This is why the velocities are different. Now how to calculate or how to identify the direction of force? Well, we know that force is equal to m multiplied by a. So direction of force will be determined by the direction of acceleration. Again, the acceleration means change of velocity divided by the time. Change of velocity means the final velocity minus initial velocity. So what I will do is that I will draw one minus v1 here so that using vector triangle rule, this v2 minus v1, which is also equal to change of velocity, becomes this one. So this is the direction of change, therefore it will be the direction of acceleration as well, therefore the direction of force will be along this way. So it will be along northeast direction. Let's move on. This question says that if the closed loop integration of electric field throughout the area is equal to 0, then which of the following statements are correct? Well, this particular integral that is mentioned, it is nothing but the total amount of electric flux over a closed surface, and it is equal to 0. What does it mean? If the total electric flux through a closed surface is 0, it means two conclusions. One, the net charge inside the surface will be 0, net charge, and then the total number of electric field lines which enters the surface, it will be equal to the total number of electric field lines which comes out of the surface. So number of electric field lines which enters should be equal to number of outgoing electric field lines. So in this case it will be 0. So option A is correct one. Let's move on. Here it mentions that the potential energy of a long spring stretched by 2 cm is equal to U. Now if the same spring is stretched by 8 cm, what will be the corresponding potential energy? First of all, we should know that the potential energy stored in a spring when it is stretched or compressed by a distance x is given by half of kx squared. We immediately understand that this potential energy is directly proportional to x. Thereby, I can write down that the potential energy when the extension is 8 cm will be, let's say, U2, because potential energy corresponding to 2 cm is U. Thereby, if I solve it, the potential energy comes out to be 4 square U, which is equal to 16 U. So option 4 is correct. Let's move on. Here in this circuit, it is described that the circuit has the following configuration, that the galvanometer which is attached here shows no deflection. If the galvanometer shows no deflection, it means that the current passing through this particular section will be 0. And under this particular condition mentioned in the question, we have to find the value of this resistance. Well, this resistance and this particular cell both are connected in parallel with each other, which means that the potential drop across this resistance must be equal to the potential drop across this particular cell. Let's say these 2 points are A and B. Thereby, the potential drop across this resistance is AB, which should be equal to the potential drop across the cell, which is 2 volt. According to Ohm's law, the potential drop across a resistance is also equal to current multiplied by the resistance. Therefore, if I want to calculate using this one, I need the value of I. I keep this relation for a moment and move to the situation where I can calculate the value of I. The question says that there is no current passing through this particular section because galvanometer shows no deflection. It particularly means that entire current flows through this. Okay. So in this situation, if I want to write down Ohm's law, the current in the circuit will be equal to EMF divided by the equivalent resistance. So this will be, or if I want to write down the Kirchhoff's law, it will be EMF should be equal to sum of the potential drop 400I plus potential drop across the resistance, which is 2 volt. So 400I equal to 8, or I will be equal to 8 by 400, which will be equal to 2 multiplied by 10 power minus 2 ampere. I feed this particular value here, and then I get that the value of the resistance equal to 10 power 2, which is nothing but 100 ohm. Option 3 is the answer. Let's move on. Here in this question, it is described that there is a transformer, and this transformer should be used in order to use a particular lamp whose specifications are given. So there is a lamp which has this specification to a 12 volt and a 60 watt, and it has to be connected to the secondary coil of the step down transformer. and the primary voltage mentioned here, it is 220 volt, and in this situation we are supposed to calculate the primary current. Thereby we know that, suppose this is my transformer, this is my primary voltage and this is my primary current, and this is my secondary voltage. So secondary voltage should be equal to 12 volt and the secondary power should be equal to 60 watt. Now since this is mentioned that the transformer is ideal, it means that, it particularly means that the input power should be equal to the output power. Input power means input potential or input EMF multiplied by the primary current multiplied equal to the output voltage, which is 60. So therefore primary current will be equal to 60 divided by, this is 220, and when we solve it, answer will come out to be 0.27 ampere. Let's move on. It's a description based question. There's a full wave rectifier, and we know that full wave rectifier consists of two PN junction diodes, center tap, capacitor, load resistance, and which of the question is which of the component remove ripple from the rectified output. Well, in the full wave rectifier, the output is like this, okay, it still contains some ripple. These ripples can be blocked by capacitor, so therefore the capacitor is the answer. Let's move on. Here it is mentioned that light travels a distance x in time t1 in air and 10x in another denser medium. What is the critical angle for this medium? Well, what is critical angle first of all? Critical angle is the cutoff angle which determines whether light will be refracted or it will follow total internal reflection. So if I want to draw the situation, let's say this is my denser medium and let's say this is my rarer medium. Let's say refractive index in the denser medium is N2 and the rarer medium is N1. Let's say speed of the light in denser medium is V2 and in the rarer medium it is V1. Now when light travels from denser medium to the rarer medium, if this particular angle of incident, if this is less than the critical angle, then light will suffer refraction, it will transmit into the rarer medium. On the other hand, if the angle of incidence is more than the critical angle, then it will suffer total internal reflection, it means it will reflect back into the medium. Now I will simply write down the critical angle formula, which is this one, N1 by N2. Refractive index of the denser medium should be in the denominator, and as I see the question does not mention anything about the refractive index, we can of course calculate with the help of the speeds, but then we can directly write that the refractive indexes are inversely related to the velocity. So I will write down this critical angle to be equal to the ratio of the velocities. Okay. Now what will be the velocity? Velocity is distance by time. So for rarer medium, which is of course air, x by t1, and this will be equal to 10x by t2. Now if I put the respective values here, sine of ix, it should be equal to 10x by t2, then x by t1. So sine of I, this will be equal to x gets cancelled, so 10 of t1 divided by t2. Therefore the option 4 will be the answer. X will be equal to 9 by 8 multiplied by 24, so this will be equal to 3, and the answer will be 27 centimeter.